Shall we wait for your friend? Or can we start? From work. Sign your attendance. Okay, guys, I think I should start. Okay, today we are going to look at beams. Yeah, beams. So last week I have covered on the topic of slab. So I think everyone here knows what is slab, right? What is beam? So you have learned it during Beacon 1, Beacon 2, right? And for today we are going to look at the theoretical part, and also we are going to look at the calculation part. Okay, what is beam? It is a horizontal structure members that is subjected to a load and tend to bend. Yeah. So the reason or the function of a beam is to support the floor slab, and it is going to transfer the load, yeah, that it support to the column. Yeah. And then of course when there is a load applied on the beam, it will tend to bend. Yeah. And then the designers should design a beams that can withstand the moment, shearing forces and deflection. Yeah. And then the bending force induced into the beam, which is caused by external loads and also in the own weight of the beam itself. So what are the external load? For example, like floors, wall, machineries, occupant, and many more lah, yeah. And then on weight is the weight of the beam itself. Some beams are made from concrete, some beams are made from timber, and some made up from steel, yeah. It depends on the type of material. And then this is actually there are many different forms of beams available in the construction of buildings. Yeah. This one is rim beam connected with this arch beam. Yeah. This is arch beam. This is steel beam. And then okay, first we will look at the continuous beam. Okay, this is how continuous beam looks like, which means that it consists of more than two support. Support means the column lah to support it. Yeah. And then extend without break in itself over the two or more spans. And then this is the behavior of continuous beam when load is applied on it. Yeah. So, okay, the upper fibers here will be in compression. Lower fibers will be in um, upper here will be in compression. Below will be in tension. And because the support is more than two, here got three support. Okay. Okay, and then this type of beam provide resistance to bending when a load or force is applied. And this type of beam usually be used for the construction of bridges and also buildings. So usually building long span structure, we use this kind of beams lah, yeah. And then we have fixed beam, which means that this beam is fixed at both ends. So usually we are using the rigid connection lah, yeah. rigid connection. I think I have mentioned about rigid connection, semi-rigid connection in Beacon 2. Okay. And then can resist vertical and horizontal forces as well as moment. Yeah. I hope everybody here still remember the term of moment, shear, right? Because in Beacon 2 I have mentioned this. So I don't want to repeat. Okay, this is how fixed beam looks like. It is fixed. So which means that it cannot be removed lah. Unless if you open up this screw lah. And then steel beam which are welded together and a cast in place concrete structure. Most common in building structure. So we usually use this type of beams. In the construction of building. And then this is simply supported beam. So made up of beams that span between only two support, which means that this type of beam have two supports, left and right. Compared to continuous beam have got more than two support. And then this is the behavioral. When load is applied on that beam, it will tend to bend. Okay. And then this type of beam is free to rotate because it is not fixed to the structure or to the column compared to the first one. So fixed beam, right? We fixed it, using rigid connection or semi-rigid connection. But this one we just put it on top of this support. And then often used in areas that are prone to earthquake, seismic activity. So because we want it to be flexible lah during the vibration, so which means that it can absorb the vibration. Okay. And then not often found in normal building structures. So we rarely use this type of structure in building. Commonly used in the construction of bridge. As you can see here, the beam is just placed on top of this another beam in terms of detail lah. It is not fixed. Okay. And then we have cantilevered beam, a fixed beam projecting from a vertical support. So usually it will fix here, column, it will be fixed on column or also column and wall. So as you can see here, upper area will be in tension, below will be in compression. Okay. And then this is how cantilever beams look like. So we have two ways, one way and two way. So this is one way lah. Two way here, another one, and here another one lah. This is two ways. Okay, left and right. Okay, another example of a cantilever beam. This is maybe what is this? Temporary shelter bus stand, the one that you have designed last semester, right? And this is a house, cantilever house. So we have a free space here. This is a roof lah, a roof to support this glass. Okay, usually the shape of beam, it is in form of rectangular. So commonly used in concrete or timber beams lah. If the direction of the loading can be predicted, then the beam can be designed so that most of the material are placed that plane. So which means that usually an engineers, they will look at the loading, the loading, especially this wall line, wall line. Usually they will place a beam lah below it to make sure that the beam can easily distribute the load of this wall. Okay. And then if you put the beam on a flat surface, of course the minimum material, it will be not that strong enough. Yeah. Minimum material in the direction of the force, which means that, okay, the beam will not be that strong to support. It will bend lah. If you put it on a flat, this is flat, on edge, of course, it will have a maximum area to support this wall. And then this is steel beam. So this is how steel beam looks like. So it is in form of H, C channel, square, but square got hollow inside. And then we have angle in L shape and T form lah. And then different shape would have different stiffness and resistance to torsion. Yeah. So the forces that should be taken into consideration when using this type of beam is torsion lah. Yeah. This force. And then we have box girder. So usually this type of beam is used for infrastructure work, for example like highways, flyover, and for MRT or LRT rails. And then stress tend to be concentrated at the corners here. The stress of the beam will be here lah. And we have cylindrical tube. This is the beam, in form of square. Okay, best if the direction of the load could not be predicted, resistant to bending and torsion. But this type of beam is not used for heavy duty lah. I mean, it will not be used for a big to withstand a big structure. Just maybe a small bridge can do lah. This type of beam can be used for this type of beam. Okay, characteristic of a beam. Okay, beam should be satisfy the following requirement. So it should have an adequate strength to resist bending moment. Remember bending moment? You know what is bending moment, right? Okay. So we not repeat. And then least excessive amount of deflection under pressure. And able to able to resist lateral bucking and able to resist shear forces. Okay. And then what is bending? Bending is a beam deflect under the heavy load. So this is bending. Okay, which means that if you put this beam on a flat, okay, so if you sit in the middle, of course it will bend. Yeah. And then a beam should be on edge, which means it can have the full strength to support the loads. Okay. Okay. When the beam deflect under a load, it results in the formation of stresses such as tension and compression. As I mentioned, there will be two forces involved when the beam bends. We have contention and compression. Okay, to see the compression and tension, so we use a sponge to test it, as a medium to test. Okay, first we have this sponge, so we draw a line like a grid line. And then when we bend it, of course we can see the stresses, the tension. Where the top one, which one is under tension, which one is under compression? Which one? Which one is under tension and which one is under compression? Compression? Compression is below. Top. Compression on top, tension below. Who agrees? This experiment to see the tension and the compression of the beams by using sponge. In your opinion, when we bend the sponge, which one is under compression and which one is under tension? Sorry? Top under compression, below under tension. Okay, correct. Which means that the top one is under compression, below one is under tension. But different with cantilever beam. Yeah, which means if you put the sponge on a wall, on a surface, so the top will be under tension, the below one will be under compression. Because the support we got only one, but this one got two support. Okay. Okay, deflection is the degree to which the structure element is placed under a load. So the amount of deflection will depend on how the load is distributed, whether it's distribute point load or UDL. What is point load? What is point load? Did I mention this in Beacon 2? I think I did, right? I did mention it. UDL. What is UDL? Uniformly distributed load, yeah? And then how the end of the beam are supported, fixed, whether it is fixed or freely supported. Yeah, I thought you went to US next week. Okay, this is simply supported beam lah, deflection become more of a problem as the span increases. Remember I have mentioned about simply supported beam, which means the beam is not how to say, it's not fixed on the support. It just placed on top of it. So of course, the longer the beam spans, the high will be the deflection or the bending, the moment, the bending lah. This is the deflection. It will move down. And then for fixed beam, the deflection is less lah compared to the simply supported beam, and because of it is fixed with these two area lah, two sides, and then the deflection of simply supported beam will be 8 times compared to the fixed beam. Okay, lateral or sideways bulking. So this is what it meant by lateral or sideways bulking. A great beam, a beam may buckle if its depth is much greater than its width, subjected to compressive stresses on top of the beams. Yeah, and then okay, this is failure due to shear. Yeah, so we have 3 types of shear. Yeah, we have vertical, horizontal, and angle. Yeah, so vertical, this is how it fail lah. Yeah, imagine a beam made up of blocks, and let's say you install a block to form like a beam, and then you put into support lah, and then you put loads on top of it. Of course, it will go down one by one lah. That what is meant by shear. Yeah. And then this is horizontal shear, which means that if the beam make up of layers, and then you put a weight on top of it, of course it will move. Okay. And then at the angle, this one at the support, at the reaction, which means at here lah, at this area or this area lah. And then forces, loads on beam. So this is what it means by point loads. Yeah, a point load, the loads is focused on one point, depicted by a single arrow in diagram. Okay, this is, let's say this is a beam. Okay, this is to support. On top of it will be, let's say, a loads, maybe another beam, or maybe on top it will be column. Okay, so this is how to represent a point load. Yeah, we draw a free body diagram. This is we call a free body diagram. Yeah, by drawing this free body diagram, we can calculate or we can quantify lah the reaction at this point and also this point. Okay, so far clear? Can you guys understand? How about you? Can? Am I going too fast? Okay, this is just a theoretical part. Yeah? Later we are going to look at the calculation. I think you're going to love the calculation part. Yeah, it's very easy. Plus minus. Yeah, that's all. Plus minus and bahagi. What call it? Subtract. Bahagi kan? Okay. Okay. How this point load works with this structure, building structure? Yeah? Let's say we have this a two-story structure lah. This is the ground floor. This is the first floor. Okay, in point load, the load is focused in one point, repeated by a single arrow in diagram. We call this a free body diagram. So let's say here, okay, this is the to support, right? To support, sorry, this is a beam, and to support by these two column, right? So this will be the point load. A column that connects with the beam and also this wall on top of this beam. Sorry. This intersection beam that support the wall. This also will be the point loads. Okay. So how to draw this, the free body diagram of this area, this area is here lah. Allah. This is the support column lah, the column. This is the beam, beam and wall, beam and wall. Okay, and this is the column. Okay, so you need to know lah because you are going to do project 1, project 2. So project 2 you are required to do lah something like this one. Okay, so far clear? Of course, in structure, we will have the value lah, the value. For example, this one is 100 kilonewton. This one is maybe 20 kilonewton. Okay. Okay, UDL, uniformly distributed load. This is how UDL looks like. Okay, UDL, the loads is spread evenly along the structure, depicted by a series of arrows or curve in diagram. Yeah, this is the symbol lah, the symbol of UDL, uniformly distributed loads. Okay, and then for example of UDL is the beam self weight, the beam self weight, wall on top of the beam, and then slab on the beam. UDL mean that, okay, usually in kilonewton per meter. So every 1 meter consists of the value lah. Let's say it is here is 10 kilonewton. Sorry, this one is in Newton. Let's say, for example here, 10 Newton per meter. Every 1 meter, the weight or the value is 10 Newton. Okay. 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 Example of a UDL in a building. For example, here, floor slab. This, the beam on weight. And then on top of the beam, the wall. Slab. Roof slab. Sorry, flat roof. Slab lah. Okay, this is on how to calculate lah. The beam size weight. So assume the initial beam size is 200 mm times 300. So the beam size, you need 2 times the density of the reinforced concrete. So the density, this one you can get it from what? From where? Which table? Which table? Last week notes, can you get in time? I'm not the module leader. So I assume that Mr. Adib already uploaded it. Have you got it? Last week's lecture, the topic on slab. If not, you have to tell me lah. I will upload it in Facebook lah. Okay, which means that you calculate 0.2 meter. Okay, of course you need to convert into meter lah. 0.2 times 0.3 times 24 kilonewton per meter cube. So the density of the material you can get it from UPBL lah. Okay. How to calculate the wall weight? So the wall height, you need to time the thickness of the wall and also the density of the bricks. Because wall made out of bricks. It's dependent on what type of wall. If it is a concrete wall, you need to get the density of a concrete lah. If brick lah, the value will be different. Here, self weight of the beam is 1.44 kilonewton per meter, and brick wall weight is 8.55 kilonewton per meter. Okay. In reality, in construction, in building structure, of course, it will be a combination lah. Some structure will have different. Some structure we have one. Maybe some structure will have some structure is in form of point load and some structure in form of UDL. But most of the structure will be combined, a combination. So this is a free diagram to represent a combination of UDL and also point load. So as you can see here, 10 Newton per meter here. The weight from here to here is 10 Newton per meter, and then the weight here at this point is 20 Newton. Okay, maybe this is the weight of the beams. Okay, and maybe this here is an intersection beam lah, or a column placed on top of the beam. It depends on the situation. Okay, don't forget to sign your attendance. I already passed the attendance sheet. As you can see here, here is the UDL wall and also this slab. And then apart from that, we have this intersection beam. A beam connect with another beam below this wall lah. This is a point load. So when we and another point load lah here. A point load from this column. Okay. So far clear? Clear? I know you are very clear. Any question before I proceed? No. Okay, good. Okay, this is how the load is transferred in a beam. Yeah, as you can see, look at this diagram. Yeah. Okay, beam will transfer the loads to the nearest support. Yeah, as you can see here, if this is a roof lah, it will transfer to this column and also this column and the intermediate column, and then another beam. Yeah, below it got another beam. So this beam got to support. Of course, it will distribute to the nearest support here and also here, left and right. Yeah, some of it will be under compression and some of it will be under tension. Okay. Okay, beam also can be used to carry the horizontal load, yeah, due to wind or earthquake. Yeah, it depend. Yeah, that's why we have many type of beam. Yeah, some of it are fixed, some of it simply supported. Usually, the simply supported one can bear lah the load from the wind or also from the earthquake, because it is not fixed. It can absorb the vibration. But if the beam is fixed with the column, so of course it will not be flexible enough, so it cannot absorb the large amount of vibration. Yeah. Are you okay? Dizzy? Are you dizzy? Okay. Drink a lot of water. Okay, as you can see here, this is how load is transferred to column. Yeah. Yeah. Got to support. Yeah. As I mentioned, it will divide into two lah. We transfer to nearest support that can reach. Yeah. Here. Yeah. Then this is how loads transfer to girders. So this is girders lah. Girders is a large beam lah. And then load transfer to wall. Okay. Okay, identify the types of loads for each beam without considering the beam self weight, whether it is point load, UDL, or combination. This one, UDL, point load, or combination. Okay, this one, beam at AB. Let's say this is a layout of a structural plan. Structure plan. AB. Okay, this one is UDL or point load? UDL or point load? Or combination? Point load. Are you sure? Sabrina. The beam is point load, UDL, or combination? UDL. Point load. Sure, it's point load. Azira. Lawrence. UDL is UDL. UDL. This one? C D H. Combination. Why? Okay. CDH because got 1 point load. Okay. This one? This one is combination, right? EFG. EFG. So this is the load of what? Slab, right? Slab. And this is the load of this intersection beam connect to this beam lah. Right? And this to support the column, right? Sorry? This one? This one? Combination, yeah? Same as here lah. EC, EC, EC. Okay, we have this to support is the column. And then here is the slab. And here is the intersection or that join together with this beam, right? Okay. Here also a combination, yeah, FBD. FBD. So this one is the slab and the beam, yeah, and then this one is the intersection. The joint beams, yeah. This one is UDL. GH. GH. UDL. This one, the UDL of this slab. Because this is a two-way slab. Two-way slab, it will divide into two, right? Half will go to this beam, half will go to this beam. The weight lah. Kan, remember last class? Kan? This one is void. No beams, no slab. Kan, it's very simple and straightforward. Huh? Okay, Rajan? Okay. Okay, when we draw a free body diagram, so this is the correct way lah. Let's say we want to draw a free body diagram of A to D. So we cannot just take A to D and we put this. We total up the load. Cannot, because we got 1, 2, 3 support. So we need to divide into two free body diagram. A and B got one support. A got a column support and also B got support, right? In the middle is the UDL. UDL may be the weight of the beam itself lah. Okay? And also the weight of this slab. Same as here, yeah? BD. So here BD we have a different value of UDL. Yeah? Because we have this slab and this slab. The value is different lah compared to this one because it is same, yeah? The flow slab is same. Okay, for your assignment, it will be something like this one lah, as I mentioned from last week. So last week slab, this week beam. So slab and beam of usually will be connect together lah. Yeah. Okay, calculate the load of beam 2/B to D. So the beam is here lah. Okay, first you need to draw the structure plan and indicate all beam and columns. And then you need to determine the type of each slab, whether one way or two way, and draw the load distribution. So this one you need to refer back to my notes, yeah, from last week, and then identify which slab contribute its load to the beam, and then you need to identify which parts of the beam carry the brick wall. Here, as you can see, this is the architecture layout or architecture plan. Here, this is the beam, right? Two support A and support B, and then on top of it is we have this. What is this? A brick wall, right? A brick wall. And here next to the beam is this lah, the slab. These two slab. So if we convert it into structure plan layout, so it will be something like this lah. This one is one way or two way? This one is one way or two way slab? Two way slab. This one is one way or two way? Two way. Three slab that connects with this beam are two way slab. Right. So you need to draw the areas which the slab divide itself lah. If we this because this is a two way slab, of course it will be in form of what you call trapezoidal area, and this one is will be triangle, right? So which area of this slab that is connected to this beam? Here, right? Here, one trapezoidal shape and two triangular shape. So which means that you need to do a calculation lah. Yeah, a slab calculation, like what I have taught you guys last week. Okay. Other than that, what weight does the beam cover or the beams carry? The weight of this slab, 1, 2, 3, live load and dead load. Okay. And then the weight of what? What else? What else? What else? What does this beam carries? The load that this beam carries? Huh? Self load. Yeah, self load. Other than that? Sorry? Yes. Brick wall here. So other than that? Ada lagi? Got tak? So we have this beam carry its own load, weight. Other than that, this slab, 1, 2, 3, the dead load of the slab and live load of the slab. And then brick wall, right? Brick wall here. Got brick wall, right? Brick wall. Because this is a room, bedroom. Ada tak lagi? Got tak? One more load. Cepat. Got column ke? I don't see any column there. Right. Column should be black, right? Black. Got tak? In middle column. Got tak black? No kan? Only this one to support here. Here and here. This is the column. Column to support the beam. One more. Cepat. Betul lah. Where's Camelia? I didn't see her in class. What happened to her? Diana, I cannot see Diana today lah. Last week she came. Tasha, right? Okay, back to my question. One more. Roof. No. Cepat. Gigi. Huh? Sorry. Okay, good. Beam here. The beam that's connect to this beam. Okay. So, okay. Yelah. The list. Dead load from beam, self weight. Okay. bricks, okay, and then slab. Yeah, we have 3 slab, right? And then live load of the slab. This is one is the dead load, live load, and then point load beams at point C2, 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 right? At point here, okay. So the next step, after you have identified all the loads that have been distributed to the beam, so you need to calculate lah. You need to find the amount of dead load, for grade BC, CD, live load. This is the slab lah, the slab. And then the free body diagram, include the free. You need to draw the free body diagram, and then find the ultimate load and draw the ultimate load diagram. So you need to analyze the beam C23 using the same step to know the reaction forces at C2. Panjang umur. Baru sebut tadi. Okay. Which would become the point loads. Okay. Here lah. Macam mana you nak buat, How to do it. List it down one by one and you calculate the loads. For example here, beam self weight is 0, let's say 1.44. And then beam brick wall 8.55, the one that we have calculated just now, okay. And the load of slab, let's say when you have done the calculation, the value is 7.2. This one is 3.6, this one is 3.6. This is the 3 slab. Okay. And then total dead load FC and CD is here lah. BC and CD, because you cannot because it is different lah, BC and CD. The weight of the size is the weight, that is support is different. And live load, okay, live load is only applicable for slab only, slab. The calculation is based on the calculation that you have done, from the slab, from the formula, that I have taught you guys last week. Okay. And you total it up, BC is for 6 kilonewton per meter, CD is 6 kilonewton per meter. And then you need to add all the slab together lah by using the ultimate loads, So ultimate loads is a load. The ultimate load is generally the amount of all loads after the consideration of safety load factors. So the purpose of load factor is to allow extra safety than intended. Usually, when the engineers design, they will put the safety factors, which means that they need to make sure that the design is more than what they actually get. When they quantify, they calculate, okay, let's say the load is based on the calculation, maybe 100 kilonewton. They need to times the factors. For live load, for dead load is 1.4, and for live load is 1.6, to make it more bigger lah, the size of the slab. To make sure that this beams or slab is really strong enough to withstand the dead load and live load. Okay. So, for example, dead load is 20.3 times 1.4. So you get this amount lah, 29.1 kilonewton per meter, and live load is 33.0 times 1.6. You will get 4.8 kilonewton. So you add it together lah. So this is how to calculate. And then after that, after you have done the calculation, you have times the live load and dead load factors, safety factors. You need to total it up, and this is the how to say it, the free body diagram of that particular beams. You know what I mean? It's not an easy task. It's not as simple as just drawing the free body diagram. You need to calculate one by one. You need to separate the element, and at the end you need to total it up and times the safety factors. So this is the free body diagram of this beam that consists of three slab, a brick wall, the beam on weight, and also this point load, the the beam that connect with this beam. Okay? Senang tak? Very simple, right? This one is the UDL. And after you have got this, after you have managed to get this UDL, you can find lah the reaction at B and also at D. Because we want to know, later we want to know the shear force and the bending moment of this beam, the value of it. Easy, right? Very simple and straightforward. Senang. Simple, right? Tak lah? Jeb ke Jeb, ya? Any question? Ada soalan? Do you have any question from me? Do you have any question? No? Tasha, do you have any question? Where's Camelia? Tak tahu. Lama tak dalam kelas ni. I'm not the module coordinator. I cannot do anything. Yeah. But I think you should talk to her to come to class. Yeah. If not, watch the rewind video. Hi, Camelia. Okay. No question. So everyone understand. Yeah. Bagus lah. Good lah this batch. Okay. Which means I don't need to. I just need to do the final exam papers lah. No need to do the receipt paper. Right. Everyone here pandai. Yeah. Clever. Okay. Okay. End of part 1. So we move to part 2. Oh, you guys want a break? 5 minutes break before we continue with part 2? I know you guys are going to love part 2. Yeah? Okay, I give you guys 5 minutes break. Okay, can I get back Okay, can we continue? Easy, right? Okay, the part two will be the beam analysis lah, to calculate the reaction at A at this to calculate the reaction at these two supports. Yeah. Okay. The loads and reaction bend the beams and try to shear through it. So this is a beam, a beam. So when the loads is applied on the beam, it will tend to bend. And if the material of the beam is not that strong enough, it will shear. It will cut into two pieces lah. Okay. Okay. To determine these stresses and strain, the internal forces that act on the beam must be identified. So first you need to find all the forces, whether the forces is point load or UDL, like the one that I shown you guys, right? Yeah. Okay, then calculate the reaction forces at the support of the beam. Calculate the support lah. Yeah, support these two supports. Then after that, you need to produce a shear force diagram and bending moment diagram. Okay, for this week, I will not cover this one. I will explain about this, how to find the reaction force. Guys, are you good here? Okay, how to calculate the reaction? Remember that a beam is static. It is not moving and not rotating. So reaction force can be solved by applying two simple rules of condition of equilibrium. A body in equilibrium has no resultant force in any direction. A body in equilibrium has no resultant turning moment in any direction. So which means that a state and equilibrium is equal to zero. Okay, to simplify the notes, okay, actually we are using two principles: the equilibrium of structure. Any structure in form of equilibrium will equal to zero. Zero lah, right? Which means that action and reaction zero. So of course it will be inform. It will be stable lah. It will be no movement. For example here, total load of structures here plus reaction force equal to zero. Okay, this is the loads going down. Okay, this is the loads that going up to support these loads. So the load here and this below need to be the same in order to be equilibrium or zero. You get what I mean? Faham tak? Okay, the one that is going up down will be in form of negative. The one that's going up will be in form of positive. Okay, that is to quantify lah. Yeah. Okay, never mind. I will repeat again after we have look at example. Okay, then we use this concept, moment. Moment, remember moment? Yeah, moment. Okay. Moment is equal to force time perpendicular distance. Yeah, here lah. So this is the force and this is the distance. M equal to F time D. Force time the distance here to the support. This is moment. Okay. Moment can be in form of clockwise, usually clockwise positive, or anti-clockwise, which is negative. Okay. Okay, first we start with moment lah. In order to calculate the reaction, we need to start with moment. Yeah. Okay, as you can see here, this is a beam that have to support. On top of it is a force, a point load. The force tend to rotate the structure clockwise about the support A. Here clock A, clockwise, right? If B, so anti-clockwise. Okay, boleh? Can or not? Do you guys understand? Moment. Okay. Oh, this is moment. This is my hand is a support. So when the pointer move, so this is moment. We call moment. It can be in form of clockwise or anti-clockwise. But here I didn't mention, as Mr. Adib said, it's clockwise. But negative one that follow clockwise is positive, anti-clockwise is negative. Okay. Okay. Let's say here, for example. Okay. Let's say apa ni? The forces tend to rotate the structure clockwise about the support A. Clockwise. Let's say here, this is fixed. Let's say this one don't have any support, so it will tend to go down in clockwise, right? Clockwise, this one. Okay, let's say this one is fixed, 0. So this one don't have support, so it will move to anti-clockwise. Kan? Tak faham lagi? Do you guys understand? Okay. We look example, okay, to make you guys more, to understand the concept, yeah. Okay, thus there is no rotation, only bending lah. If got two support, of course there will be no rotation, only bending. Okay, rotation will occur if either support is removed. So in order to calculate this, to find the reaction at one point using the moment concept, you need to bayangkan, you need to imagine that there is only one support to make it rotate. Okay? Kan ah? Takut I tengok ke? Scared lah when I look at your faces. Seem that I have to do another paper lah, the receipt one lah. Just now I thought I don't need to do. Okay? Okay. We look at example. Okay? Okay, calculate moment at each point, yeah? For example, this is a beam. So, and then this one is a point load. So usually we have distance lah, yeah? And the total load, here, I don't know, what is this envelope one? Okay, we skip this one. We look at this one. Okay, this one is UDL. UDL, 2.5 kN per meter. Each 1 meter, the value is 2.5 kN. So, in order to calculate this one, UDL, you need to convert this UDL into point loads. That is the rule. Okay, how to convert it? You times lah 2.5 kN per meter times the distance from this end to this end. So 2.5 times 4, you get 10 kN. 10 kN. So this 10 kN will be in the middle lah. In the middle. Here. Okay. So the load is equivalent to a single point load of the 10 kN in the middle of the beam. Okay, here a uniform load on a beam is shown below with a value of 5 kilonewton per meter square. Sorry, 5 kilonewton per meter. So distance is 6 kilonewton. Okay, as I mentioned, you need to convert this into point load. 6 times 5, you get 30 kilonewton lah. So of course, because it is balanced, right, in the middle here, yeah, as I mentioned, the load on top will be the same, the load that supports it. Right, you divide into 2 lah. Right, 30 divide by 2, you will get 15 kilonewton here and also 15 kilonewton here. Yeah, because it is sama, same. Only one support in the middle. Okay. Okay. So this is the correct way on how to calculate lah. Yeah. Choose one reference point. In the example, we choose point B. Point B is a fixed one. Okay. Calculate all the moment from A B to get RA. Balance all the forces to get RB. Okay. Okay. We are using the concept of moment. Moment. Remember moment. Force times distance. Okay, let's say we take RA. We want to calculate the reaction at RA. So which means this one is fake lah. This one can rotate. This one is 0. Right? 0. Okay. RA going up, right? Going up. So it is positive. Okay, RA times the distance is 6 meter. Right? Plus that loads that going down. Load here, 30 kilonewton, which is in a negative rotation, anti-clockwise lah. So in bracket plus negative 30. Anything going down will be negative. 30 times 3. 3 is the distance here. Here, to the fixed beam here, to the ni lah, rotation area. Okay, so you solve lah the equation. So you get RA equal to 19 divided by 6, you get 15. So this is how the correct way on how to calculate it. Can tak? Boleh tak? Can? Okay, this is for moment. Okay, this one we use total F for vertical forces that going down lah, equal to 0. Okay, reaction A plus reaction B plus going down is 30, right? So in form of equation here, you will get this 15 kilonewton. I don't think I need to explain about here how to calculate, right? The equation. You have learned this, kan? During your primary school lagi. Kan? Secondary school. Boleh tak? Kan tak? Okay, take a look. Okay, take a look and try to use your calculator ke whatsoever to calculate, to check the value here. Is it correct? And try to understand this. I give you 3 minutes. The one that moves is this point. It's going up Okay, so everyone can understand this calculation, how this calculation works. Can ah? Can ah? Boleh? Azira can? Senang, easy lah Just a piece of cake. Like eating kacang, eating kacang with your girlfriend or boyfriend. Huh? You be kill lah. Okay. Okay, how about this one? How about this one? Now consider a uniform dead load of 2.5 kilonewton meter over part of a beam. Yeah? Here got UDL. The UDL. Okay, and then the length of the UDL is 1.5. And then got two support A and B. The total support, the distance between each one support to another is 4 meter. So same lah the concept. You need to convert this into point load, right? So 2.5 times 1.5, you will get 3.75 kilonewton. Okay. So the distance between here, so you need to divide lah into two. 7.7 0.75 here to here lah, and then here to B, so 4 minus 0.75 lah, right? That is the new distance of the point load. Okay, can lah? Boleh? Easy right? Sabrina, can lah? Have you learned this before? Oh, you have learned this before in your secondary school. Oh, good lah. Oh, your favorite subject? Oh, good. Okay, here on how to calculate it. Yeah. Let's say RB is the reference point. Yeah. Same lah. So RA, you want to calculate RA, right? So RA times 4. Times 4, the distance between RA to RB, 4, minus 3.75 times 3.25. The distance between here to here. Right? Right? Yeah. Why negative? Positive combine with negative, positive or negative? Negative lah, right? Positive with positive with negative, we become negative. Nanti orang tanya pula so I have to mention lah, this one become negative lah. Okay, so this is the equation and you are required to, you need to solve this equation lah. So RA is 3.05. Yeah, RA here 3.05. So RB, RA plus RB plus minus 3.75. Why minus? Because the load is going down. Right? Solve this equation, so you get RB is 0.7 kilonewton. How to know is the one that you get RA and RB is correct. Try to add this together. 3.05 plus 0.7. Did you get this the same? Which means betul lah. Okay. Yes. one that is going down is MB1 lah. MB1 tu, it can be MB1 or it can be anything. Okay, MB1, MB2 ni I just put here to make sure that you guys can understand the concept. Not necessarily MB1 or MB2. You just follow the direction. If let's say here is the reference point, Okay, let's say we can move this beam, going up and going down. Okay, the area here the one that's going up is positive. The one that's going down, the anti-clockwise one, right, is negative.
So that means that MB1, MB2 in here is supposed to point for point B.
Yes. Yeah, yeah.
Not means if point A has other direction.
I don't get you. Tak faham.
No, because now the arrow direction is down.
Okay, it's just the how to say it? The arrow is just to show whether it is positive or negative, clockwise or anti-clockwise. That's it. Let's say you have another support here. Of course, there will be another arrow, right? Maybe let's say another more support, another arrow, right? But you have to know whether the arrow is negative or positive. Anything that is clockwise is positive. Anything that goes to anti-clockwise is negative. That's it. There's no issue of MB1, 2, 3, 4, 5, 7. Okay? It's just for your reference only. Okay? Can? Am I answering your question? Yeah? Guys, I repeat, yeah, this MB thing, MB1, MB2, is just for your reference. That's it. The thing that you should concern about is the how to say it? Whether it is negative or positive. That's it. Okay? Okay, try to calculate this. Calculate the reaction forces A and B. Okay, do it now. Give you guys 3 minutes. Okay guys, convert these two UDL into point loads. This one point load, this one point load. And it should be located in the middle. Here, in the middle here, and also in the middle here. So which means that you need to adjust the distance. Okay lah. Right. guys? Clear? So what is RA and what is the value RB? Okay, this is result. RA is 9.8, RB is 13.2. Did you get it correctly? Got it correct. Good. Okay, good. How about you? Hika? Okay. Okay, I want you guys to look at this answer and try to understand it. If you cannot understand, you can ask me. Okay? You can ask me now. Okay, anything clockwise, positive, anti-clockwise, negative. Okay, this one 5. 5 is this, the value. Then 2.5 times 2, 5, right? Yeah, going down. So this 0.5 distance. Distance. Yeah, distance here, 1 plus this 2 plus 1, right? Another 1 plus 1, 1, 1, 1. 1 meter total. Meter. Betul lah. Jadi meter total, you minus 1. Ni. Here, point load, from here to here. Minus this one is divided into two, right? So you divide it This one is 1. Right. 6 minus 1, 5 lah, right? 12. Look at your diagram. One, zero, 6 minus 1, 5 lah, right? We take that one, R8, RB as the reference point. RB as the reference point. When we convert UDL, we put the point load in the middle of this UDL, the distance of UDL. Yes, center of gravity. Guys, why the question? Okay, I have one question to ask you guys. Okay, why do we put in the middle the point load? Because this UDL we convert into point load. Why do we put in the middle? Because it is center of gravity, middle. Enough. Okay. That one is another topic lah, but it's not covered in here. Okay. Yeah. Good. Thank you. Point of center of gravity.
I was like, maybe I'm mistaken.
Which one? Which one? Clockwise, positive. This one is wise, right?
Oh, okay. Because I didn't know. I see the green one is negative. So I saw it negative. I can't say.
Don't worry about the coding. Don't worry about the color.
Okay.
Anything that is clockwise, positive, and clockwise, negative. That's it. Okay. Okay, guys. So, okay, guys. Here, RA times 6. RA times 6. This is the total distance. So we take B as the reference point, which means the B is fixed, it's in equilibrium, 0. It just can rotate. Okay? Okay. 5. Where did we get this 5? From here. 2.5 times 2. 5. And it will be located in the middle. Right? So which means that the distance between here and to B, the reference point, is 5. Right? 6 minus 1. 1 here. 5 lah kan? Okay? And then here Same. 4 times 2, 8. 8. 3 is here. 3 is distant from here to here. Okay? Can? Okay, if you guys cannot see this kind of diagram, maybe you can modify this diagram to make sure that you guys can understand lah. Yeah, put the point load. Okay, like this one lah. Simplify it like this one. Okay? Boleh, can? Okay? But this one is for your reference point, reference lah. Later you need to use this, yeah, to draw the bending moment diagram and shear force diagram. Okay. Okay, 10 kan here, this is 10 times 1. Okay. And you solve the equation. You get 9.8. Same goes to here. The vertical loads. Yeah. Going down, negative. Going up, positive. So RA plus RB. RA, we know the value, 9.8. Plus RB, we don't know. Plus 5 kilonewton. Sorry, plus negative 5 kilonewton plus 8, negative 8. Because it is going down. Okay, solve the equation, you will get, okay, another one, negative 10. You add it together, solve the equation, you will get 13.2 kilonewton. Check whether it is correct. 13.2 plus 9.8. Can you get the value of this? Add this together and compare. Is it the same? The forces going down equal the force going up. These two forces.